How do you determine the length of a radius?
The measure of the central angle of a circle that intersects an arc.
Say it one more time, nice and loud.
The measure of the central angle of a circle that intercepts an arc.
Okay, so if we take a circle
Equal length to the radius.
and then we take the radius of that circle from the center to the outside, we call that R. Then if I take that same length, whatever it is, and measure it around and connect it back, then that angle we call theta. Theta is going to be equal to 1 radian. Okay. Now, we went ahead and followed that out, right? And we said how many radians are in a circle? That's kind of like our next question, if you will. How many
No, we don't have one.
radians are in a circle? I thought we talked about that, or maybe put them in on a circle. We did? Do you know what the answer was? Okay. What is that?
I thought I could put it on one.
Not 1, because this is 1. That's 1 radian. So how many of those are in an entire circle? Yes.
5.
Say what? 5? No? I'll give you a hint.
4,
Pi is somewhere in the answer.
3. That's almost easy.
Where's your notes from last week?
I know it's from last week, you're like, no, I thought it's.
Oh, that's
At
not
home.
everything.
I'm so mad.
Okay, so if there's, what Giselle has in her notes is she has written that pi radians, and we don't normally write anything afterward, we just write pi, but pi radians equals 180 degrees. So how many radians would be in an entire circle? 2
Ah.
2 pi. 2 pi radians. Okay? Because if you were to do this R again, just for demonstration purposes, if we were to do an R again, it'd be about right there. If we do R again, it comes down, and it's not quite 180 degrees. It's just a little bit off, which is why pi radians equals 180 degrees. Okay? And then, of course, if you do it again, that's 2 pi radians equal 360. All right, so then we did this last week, so let's just do this real quick as a little reminder.
Oh, can you put that?
Sure, quickly. By the way, you need to watch what you say. Don't cuss me out because the camera is rolling. Look at you. We good? Okay, let's move on. So we have a circle. Whoops. Let's back up and do that and try that again. Let's do it here. Okay, and if you remember, last week we drew and we said, okay, we have an XY axis. And what was the angle called? We had standard position was here. And what was the angle called if it was right on an axis? We called that, it's a 90-degree angle. We called it a right angle, a special name for it in trig.
Quadrantal?
Quadrantal, very good. The quadrantal. Then we wrote in a whole bunch of degrees. If you remember, we wrote in like 0 degrees. Well, that's also going to be 0 radians. Up here we had, over here we had 180 degrees. Well, that's also going to be how many radians?
1,
No?
2.
No? Starts with the P.
Hi.
Pi radians.
Okay.
Okay? Or you could simply do the, last year they made fun of the way I wrote the pi symbol, but I'm going to write it like a little house every new time. So pi. So then here, Monty told us is 90 degrees. What would that be in radians?
0.5 radians.
Yes, so we write it as 1/2. We write it as 1/2 pi or pi over 2. Because it's half of a pi. This is a full pi, that's half a pi. I thought a full pi was round, but that's 2 pi. That was a bad joke. All right. So, someone help me out then. What's this one down here? We know this is going to be 270 degrees. What would be the radians?
1 1/2.
1 and 1/2, and we're going to call it 3 pi over 2. And then we already know what's a full circle. 360 degrees or
0.
radians. 2
Pi.
2 pi radians. 2 pi radians. Very, and we can keep going. 3 pi radians, 4 pi radians, 5, 6. We can keep going around the circle just like we do with degrees. Okay. 2 pi radians. Is this circle kind of cockeyed?
Yes.
Okay, from right here it looks like it's perfectly straight up and down, so please forgive me.
And actually,
Yeah.
like,
It's a
Okay, I
little,
can see that.
little tilted. Hey, the earth is tilted.
um,
So can my axes. Okay. All right. So then, that's kind of an introduction to what we're going to do today. And one thing we're going to do today is we're going to convert. We have the definition of it. I believe I gave you a formula today, correct? Another review thing. I gave you a formula that looked like theta equals S over R. And what was theta?
1 radian, or the what?
The middle of the circle?
radius.
The angle?
What?
The angle?
The angle, the central angle. So theta is the central angle. What was R?
Radius.
Radius. And what was S?
The arc length.
The arc length, how long it was across. So I think we ended up with an example, or maybe we didn't do the example. We said, what if we have a situation where the radius equals 6, and the arc length, a little bit of geometry terms there, was 15. What is the angle that intercepts that? I believe we did this one already, correct?
Yeah, we did.
We did?
Thank you.
So we would say the central angle would simply be 15 over 6, which gives us 2.5
Radians.
radians. Okay, so we simply use that formula, arc length. We're gonna come back to that one here in just a little bit.
So this one, would it be 2.5 pi radians, or would it be 2.5?
Just 2.5. Because there's no pi involved, it's just 15 divided by 6.
And then for the actual circle ones with like the angles, that's when we do pi.
We're gonna do a whole bunch of in terms of pi, yes. Although, they're not all, they don't, how do I say this? They don't always have pi in them, because like this one's just 2.5 radians. But when we talk about an angle, we'll almost always put it in terms of pi. Okay, just sometimes when we have arc length and radius, we don't always have that. All right, so let's talk about some conversions. This is the new thing, I guess it's Roman numeral 2 in my notes, and that's conversions. Okay, so the first thing we're gonna do is degree to radians, degrees to radians. So if I have degrees, if I tell you it's 30 degrees, and I'm gonna ask you, okay, how many radians is it? Okay, all right, and there's gonna be a whole bunch of homework problems, there's gonna be a whole section on the test, simply convert. And we're gonna have a quiz over this, just simply convert it. So I wanna go from degrees to radians. So all you're gonna do is you're gonna multiply by, oops. Can't get my notes settled. We're gonna multiply by pi over 180. Because pi and 180 is the same thing. Pi radians is the same thing as 180 degrees. So pi over 180 is actually simply, I'm multiplying by 1. I'm just changing it to a different unit. Okay, it's my unit multiplier. Okay. So let's do some examples. Let's do the basic one, number 1. Let's do 30 degrees. Now we'll convert it.
Oh.
It's all right. So I'm simply going to take that 30. I'm going to multiply by pi over 180. So we end up with 30 pi over 180. How does 30 and 180 simplify?
Is it
Say it again.
6?
1/6. So it's 1 pi over 6. Think about the zeros cancel, 3 over 18 is 1/6. So pi over 6. Now you will find all of these will have pi in their answers because I'm multiplying by pi over 180. So number 2. What if I give you, we already did that one. Let's take another one. Let's try negative 135 degrees. Because remember, we can have positive or negative angles, right? Positive goes counterclockwise, and
Negative goes clockwise.
negative goes clockwise. Or let's see, left and right, yeah. All right, so negative 135. We would take negative 135, multiplied by pi over 180, which gives me negative 135 pi over 180. And how does negative 135 and 180 simplify? Reduce that fraction. What do you get? Some people are cheating and using their phones.
Let me get a real calculator.
Or just
Okay. I asked first.
Thank you, Jennifer. You're gonna get this answer quick. What's 135 divided by 180?
Negative 135?
Yeah, we'll have a negative here. Let's add it.
0.75?
Say it again.
0.75?
So 3/4, right? So negative 3 pi
It's okay, we're
over 4. Because we're not in class, this is one of those things too. We're not going to mix decimals with pi. You're not going to give me 0.75 pi. You're going to give me 3/4 pi, which is a fraction.
Well, just like the calculators, will they get decimals?
If it's set up to give decimals, it'll give decimals. Yeah.
That's what
And there's a setting in there that you can change to where it will give you fractions all the time. So. Okay? Do we need another example or are we good?
Okay, one more.
One more, absolutely. Number 3. Let's give you, let's see here. Let's go, hold on. I had it in my head in degrees, can't do that. Let's try 120 degrees. Try 120 degrees, give me that in radians.
How do you make it go to fraction?
You have to divide 120 by 180.
Is it giving you a decimal?
I'm just cut like that.
Well, for the decimal, I got 2.09. I don't have that.
You don't have to divide.
Oh, you're kidding me.
Don't divide.
Should just pop up, would it?
Okay. Sorry, I'm just too intelligent.
Sure. That is the right answer. It's just in a fraction.
No, it's not.
Yes, it is.
2.9 doesn't go to 2/3 of my
And it's not 2.9, 2.0. So technically it's 2.1.
Okay.
Well, apparently my little thing isn't gonna work. So if you take your calculator and you go home,
She already did it. She just put pi in there.
you don't have to put pi.
That's what
I see that now.
So what'd you get when you did 120 over 180?
2/3.
Yeah, there you go. So it's 2 pi over 3.
Okay.
But if you'd like to do that, if you go to the home screen, hit settings. My calculator's getting there very slowly. But there's a setting in there where you go from approximate to
This is gonna be section.
auto.
This is right.
Auto should give you decimal. Okay, so we good. Give me the answers, and now I just want to remind you what we're doing, and the fact that we're not really, all we're doing is converting. Rather than saying 30 degrees, I say, what's the angle? You're gonna tell me it's 5 or 6. You're just giving me a different answer, a different way of answering, rather than degrees.
Does it get harder than this, or this is just it? No, this is, just to make sure.
All right, radians to degrees. Okay, so what am I gonna multiply by?
Pi over 180.
Well, that's what I was multiplying when I did degrees of
180
radians.
over pi.
180 over pi. 180 over pi. Now, someone refresh our memory. I told you a story that in my high school trade class, when we got to radians, our teacher gave us a 2-minute speech and said, this is what you gotta do, then he said, do your homework. What was that one?
Pi.
What'd you say?
180 pi.
180 is pi. So you'll see how that works here. Number 4. Let's give you something in radians. Let's say I give you 5 pi over 3. And I say convert,
Wait, 180 over pi is 1, right?
yes. Because 180 degrees divided by pi radians is the same thing. So if we do that, if we multiply by 180 over pi, I have 5 pi over 3 times 180 over pi. So what's gonna cancel out?
The pi and 180.
The pi's. It's just like the 180 went in its place. Because you simply multiply by 180 over pi, these cancel, and you have 5 times 180 over 3. So it's just like replacing pi with 180. Okay? And you get what? 300. 300 degrees. So 5 pi over 3 is the same thing as 300 degrees. Is that right? Yeah.
That's nice.
So it's kind of like just taking out the pi
Cancel out.
and putting in 180.
It's 5 times 180 over 3.
Yeah.
5 times 180 is 900, divided by 3 is 300. I do believe. I think that's right.
No, it's 30.
Sure.
Okay? How about this one? Pi over 3.
That was you get. You're not
60
done.
degrees.
It's, yeah, mm-hmm.
Because it's like saying
Yeah.
pi
Right with the reaction.
over 3 times 180 over pi,
Cancels out.
which is like saying
Not
180
divided by 3.
over 3, and you get 60
Yeah.
degrees. Are we good with that? Do you need to see another
Yeah.
example? Are we good?
No, we're good.
What's that?
We're great.
You good?
How many of like on the quiz, how many of questions are gonna be like conversion?
He doesn't know you guys made it.
Yeah, probably. A quiz will do a few more. I'll try to do a couple tricky ones in there. Test. Just basic. Yes,
So you know how you said 180 is pi?
yes.
On this one, it wouldn't cancel out, like 180 and then the pi wouldn't cancel out, just the pi and the pi.
Correct, because 180 degrees and pi radians. So it's like saying, rather than, on this one, let's say we do pi over 4, it's like saying, rather than having pi radians, let's just make that 180 degrees over 4. So they just divide 180 by 4 and you get 45.
So 180 and pi are the same, but 180 degrees and pi are not.
Say it again?
180 and pi are the same, but then 180 degrees and pi isn't, because we do degrees in this one and it doesn't cancel out.
Yeah, they're different in what unit they're in. Correct. Because it's pi radians, 180 degrees, 2 different units. It's like saying 36 inches and a yard. Are they the same?
Yes.
Yeah, they're equivalent, but they're not the same units. A yard is not the same as a foot. But they're equivalent units.
Right.
All right. So let's look at some equations in standard position. Okay. Let's look at some degrees or some angles. And if you remember standard position, right? I'm going to give you 4 to look at. So let's look at A. And I'm just going to start notating this way. Theta equals pi over 4. Pi over 4. Okay, so if I was to put that in standard position, what quadrant would it be in? Pi over 4.
What quadrant?
Huh? Pi over 4.
So we have to put it in, what do we have to put this
Fourth
into degrees?
Okay, so that's what I kind of don't want you to do. Okay, did you hear what she said? She said, well, we transfer it to degrees. I kind of want you to not, because if we transfer degrees every single time, then you'd be converting every single problem. I just kind of want you to know, like if I were to say, this is actually 45 degrees, now you can all tell me what quadrant is it in.
Yeah.
Where?
The first one.
First, it's right here. Pi over 4, first quadrant. But I don't want you to think, having to go through 45 degrees, I want you to think about, oh, well, pi is 180 divided into 4 sections. So 1, 2, 3, 4.
Wait, what?
Pi divided into 4 sections.
Wait.
I'm sorry, you yelled at me for what reason?
What is pi divided into 4
We need
sections?
to-
Why'd you
Okay,
want
hang on.
to
I used an eraser instead, so give me just a second. So it's taking pi, which is 180 degrees, right? And divide it into 1, 2, 3, 4 sections. I'm taking 180 degrees and breaking it, dividing it by 4.
So if it was,
So if it was 8.
so we start like 1, 2, 3, 4, and that's how it's like going back.
Other direction, actually. You start here. 1, 2, 3, 4.
It would be 90.
How did I know it was going, how did you know it was going this way if it's?
Okay, so remember this is 0 radians, right?
Right.
And this up here is pi over 2 radians, or 90 degrees.
Oh, I wasn't.
So
here
pi over
that
4
day.
is in between.
We need to watch those videos.
They don't work for me. I wasn't here that day.
Okay. All right, so there's pi over 4, standard position. All right, let's give you another one. Let's have you try it. B. Now, honestly, if it works right now to take it and put it into radians, or to degrees and kind of think about where it is, but I want you to move away from thinking of it in terms of degrees. It'll help you go much faster. So theta equals 5 pi over 4, okay? 5 pi over 4. Think about that. Remember, your quadrangles, this is 0. This is pi over 2. This is pi. This is 3 pi over 2. Think about where 5 pi over 4 would be. And yes, the cheat thing off the back I threw away.
Oh, I didn't even notice that.
Yeah.
I wouldn't even think to look at it.
Good. What quadrant would 5 pi over 4 be in?
Second.
Say again? Second?
Mr. Phillips, wait. wait, what do we do with the top?
Third.
Do we multiply
Third.
or do we divide?
She's talking, don't interrupt her.
What do we do with the top?
What do you want to do with the top?
It's 5 pi.
Uh-huh.
So do we multiply, divide?
Well,
subtract?
we just converted, so if you want to convert to degrees. Yes,
It'll be in the third quadrant.
why?
Because like third quadrant is from 180 to 270, right?
Uh-huh.
And this one was like 225.
Okay, so he just changed it to degrees and realizes this is 225 degrees, so it actually falls
That's what I did.
right
That's
here.
what I did.
That's what I did, but I didn't know it was right or not.
Then
But
you
wait,
didn't
so
have to do
that's-
that because you said 2.
Over 4.
Look at my calculator. I just
Mr.
did, I
Phillips,
just thought.
You, that's what I said, I multiplied the top, I did 5 times 180 divided by 4, and I got 225.
Let's go back and rewind the tape and you explain to me how I would have gotten that from what you said.
Huh?
Because you
I did 5 times 180, which equals
So this one,
900,
You didn't say
and
that
I
you
divided it by
converted
4,
it.
which is 225.
Okay.
But I didn't know it was the right answer or not.
Well, now you know.
so this is not how we're supposed to do it?
So
Sorry?
if I did it on the test like that, would it be right?
What's that question?
So this is not how we're supposed to do it? We're not supposed to do it?
So, for right now, until you learn where they are, I just want you to rely upon that. In 4 weeks, if you're still taking these, converting them to degrees, there's gonna be a problem, you're gonna be going way too slow. So I want you to learn, as you learn where they are, we need to stop thinking this is, as 225 degrees, this is 5 pi over 4.
So if I did that on the test at that time, it would be wrong.
No, as long as you find the spot, it's just gonna be slow.
Like it's gonna get harder.
It's just gonna be slower, you gotta know them. I want you to not lean upon degrees. All right, letter C, try letter C, standard position. Negative 3 pi over 4. Where would it be in standard position? Unless when I'm actually introducing you to a new term.
So it's negative 540. It's negative 540 over 4, right?
See?
It's negative 540 over 4, right?
Okay.
Which reduces to.
-4.
Is it 135?
Yeah, but would it be in the fourth one? Would it be the fourth one?
Yeah.
Would not be the fourth one.
It's negative.
It's not negative anymore.
You got an answer?
It's not.
You should be listening to Elijah. That's what I tell you.
Trying to.
What do you got? Don't forget the negative though.
Yeah, negative. Oh, negative, right?
It's positive because negative 2 is negative and negative 4 is
They know.
Huh?
because you put the negative in the front and both is negative, right?
See, I wish I did leave my notes at home.
What number did you say?
I said negative 135.
Negative 135. So negative 135 means rather than going this direction, we'll go counterclockwise. And negative 135 is right there.
Yeah, I knew that.
Now,
How is it in the same quadrant as 225?
Because it's counterclockwise.
that's a very interesting question. And that's my point on this one. Okay?
Oh.
So hold on to that thought, finish writing it. Maya, did you have something?
No, I was just gonna say like before. I was just gonna
Look
say
at you trying to get
What's the
started
answer?
on it now.
oh, it's on the third quadrant.
Yeah, they're both in the third quadrant. In fact, they're both in the exact same place. Okay? 5 pi over 4, which happens to be 225 degrees, and negative 3 pi over 4, which happens to be negative 135, are in the exact same location. Okay, they're the exact same spot. Why? Why do they happen to be in the exact same place?
Because
Yes.
the
Denominator?
No?
because that's when we did it like I don't know actually never mind.
Okay. Why are they in the exact, tell me, why are they in the exact same place? How far apart are they?
90?
I'm sorry?
90?
No, if they were 90, it'd just be in one quadrant.
They're 180.
Nope,
45 degrees.
nope.
145.
How far apart are they?
You're just speaking deep.
No,
Hold on, let me do
it's
this.
90, right?
I'm sorry?
It is 90.
It's 90.
It's
360.
negative 135, not,
So negative 90?
360.
I'm sorry?
36.
Yeah, so it goes from negative 135 to a positive 225. They're 360 degrees apart, which means it's simply one revolution around is the difference.
So that would be one, that'd be one radius, 2 radius.
Hang on a second, what's that?
Like, if it goes like one, how, that'd be 1 or 2 radians?
Well, it'd be 360 degrees or 2 pi radians.
Okay.
I'm just gonna refer to it, rather than degrees, ladies, stop talking. Rather than degrees, I'm gonna refer to it as 1 revolution. It's 1 full revolution around. Now, there's a name for these that land at the exact same spot. It's called co-terminal. Remember that whole word we had about the terminal side? We have standard position, they both start in the same spot. It's just one goes negative, the other one goes positive, but they end up in the exact same spot. They're called coterminal.
That made my brain hurt.
And there is an infinite number of coterminal angles.
That was in this kid.
13 pi over 4 is also exactly the same thing.
Wow.
Because it's just one more revolution.
It would be positive 135?
Yes, positive 13 pi over 4. Negative 11 pi over 4 would also be negative, would also be in the same place. They're all coterminal.
Does it have anything to do with the denominator being the
What
same?
I'm doing is I'm actually adding 8 pi over 4, because what is 8 pi over 4? 2 pi, I'm just adding 2 pi to each one.
Okay.
Added 2 pi, added 2 pi. But it doesn't matter about the denominator, because we can do any fractions we want. Okay? It's just another rotation. So anytime you land at the exact same point, it's called coterminal. Okay? Doesn't matter if I go clockwise or counterclockwise.
So
All right, there
on
you
the,
have coterminal.
so,
So what, I'm sorry, what?
so if on the quiz, like, you would ask us like to solve it and then ask if it had a coterminal? Or just the?
I probably won't even ask if they're coterminal, it's just good to know that they're full revolutions, they're coterminals. I doubt I'll ask you to find one.
Okay. This one, we just have to like remember that we just add 8 pi over 4.
Okay, so let's look at one. Let's look at some coterminals. This would be like number 3. Look at coterminal for just a second.
What's the
Uh,
second?
So, angles, sorry. My hand kind of slipped. Coterminal angles. Okay, so let's just throw one up here to help us remember. If I take, and we'll do this one in degrees just so we can kind of see it. Let's say we're right here. And we'll call that 200 degrees. Okay? What is its coterminal? Rather than going positive, what would be its coterminal going negative?
Negative 160.
Negative 160. Because
Yeah.
it's just simply a difference of 360 degrees. Okay, so those are said to be coterminal. Okay. So the problem comes in then when we get an answer that's not between 0 and 360. Okay, because remember we talked about how we can keep doing revolutions over and over. We can have a 5,000 degree angle. Okay, so let's say we give you an angle measure of 420 degrees. So typically, we don't like to deal with angles that are bigger than 360 or less than 0. Kind of standard answer, we want everything between 0 and 360, or if we're talking radians, between 0 and 2 pi. So the answer might say, put your answer between 0 and 360 or 0 and 2 pi. So how would I convert this and find its coterminal? Yes, you have a question?
So a coterminal is always gonna be a positive and a negative.
Coterminals will typically always be positive, because we want it between 0 and 360.
So like, our first one is gonna be like the positive and not the other one that like adds up to the same thing. The other circle is gonna be negative.
Not necessarily, because this one's positive, and I'm going to give you a coterminal that's positive, because it's greater than 360.
Yeah.
Okay, so how would I determine its coterminal angle?
Pick it apart.
You simply subtract 360 degrees. So what is 420 minus 360?
180.
It's 60. It's 60.
60.
That's way off.
So my answer is 60. So my coterminal is 60 degrees. And that fits within what I want, my 0 to 360 proper term. Okay.
Mr. Phillips,
Yeah,
if the 420 was negative, would you still subtract 360?
letter B. What if I have negative 120? Am I gonna, if I subtract 360, I'm gonna get further in the negatives.
Add
So you
360.
I just add 360.
Could you add like,
Okay? So I'm gonna get
480.
240 degrees.
Yikes, never mind. What?
Watch your negatives.
oh, with the
Together. Crazy.
Are you guys laughing at me? Did I just?
No,
No,
no.
480 was
Because
the
we added
answer.
120 and 360 instead of doing
480.
negative.
Both at the same time. That's
I
crazy.
thought you were looking at
It's
me
not
and I
even
was like,
coterminal, actually.
stupid.
So if you just add 360.
My mistake, y'all.
Yes, until you get between the two.
I spit stuff out so fast, I'm like, yeah, this is definitely right, and then it's not.
So, to answer that question, what if I give you one that, and I'm not going to do this on a test, so don't even ask, but just hypothetically, what if I gave you one that said 2,370 degrees?
We divide.
By what?
360.
No.
Okay.
By 180.
You have to,
Subtract 360.
Scholar, I think we're getting really ahead of ourselves.
You get 2010.
Mine is, and then you could just keep
I was
subtracting.
3.
Subtract 360 again.
Period. I know what I'm talking about. Or you could just 360.
Keep subtracting?
Until you get between 0 and 360.
Okay.
yeah,
so
cause
this is what you do.
I was
You do.
gonna,
This is what you do.
I was gonna ask like
360.
how many times,
times
like my
6,
first
right?
instinct was
Yeah,
like
that's what I was
times.
thinking.
Can we do that?
Wow, do you guys realize he's trying to talk to me, ask a question? Did you guys realize that at all?
Sorry, Marty.
Thank you. Marty, please start over.
Now, I was gonna say like, when you were like doing it, like my first instinct was to see how many times like 360 would go into 270, like before we.
Yeah, so if this was, I mean, we could take any multiple of 360. We could subtract 720, we could subtract 1440. You know, if you happen to know a number that's a multiple, sure, subtract that. Because I don't really care how many revolutions there are. I just want a number between 0 and 360. So however you get there, faster is better. Okay? But if you get stuck, just start subtracting full revolutions. All right, so then, what about D? Rather than degrees, we did the same thing, but it was with radians. Let's say I gave you 17 pi. Now, we're gonna find out how weak you are on fractions.
Week.
Because we give you 17 pi over 6. Now, what am I gonna subtract? Because obviously 17 pi over 6 is greater than 2 pi. Okay, so what would I subtract? I want to subtract 2 pi,
Oh.
but I have to have a common denominator. So what am I going to subtract? Say it again, Savannah? Not going to subtract 6. That's 6 is my common denominator.
6 pi.
No?
Wait.
Remember, I have to have 2 pi, so I have a denominator of 6.
Subtract 2.
So what's the numerator going to be?
12.
12 pi.
Where did you get that from?
Because he did 6 times 2 to make sure like they have the same.
Oh.
Yeah, that makes
So then you end up with 5 pi over 6. So 5 pi over 6 and 17 pi over 6 are coterminal.
Is this gonna be on the test?
Oh, yeah.
Okay.
Oh. You could
See,
have
like,
been concerned about that test.
I know, everyone's concerned about the
Yikes.
quiz and test. Although I will tell you, it may not be like convert this, or it may not be find the coterminal angle. It'll just be you end up with an answer, and then you have to reduce it.
Okay.
It's like saying, will there be reducing of fractions? Well, not directly. Is Jennifer having a hard time today? You're having a hard time today. Do your best. Okay. All right, let's do one more quick example. What if I give you negative pi over 12? First of all, it's negative, so am I gonna add or subtract? I'm gonna add, and what am I going to add?
2 pi. Oh, never mind.
In what form? I'm going to add 2 pi, but obviously I have to get a common denominator.
So it's gonna be 24.
It's just gonna be 24.
Over 12.
I'm just gonna add 24.
2 pi over 24?
I'm sorry?
2 pi over 24?
I'm going to add 2 pi over 24.
Big scholar.
24 pi over 12?
24 pi over 12.
He's saying it like this. Basically, you're wrong. Well,
That makes sense to me.
Oh.
Because 24 divided by 12 is 2, and they have a common denominator. So you end up with 23 pi over 12.
positive.
23 pi over.
But you can just do anything.
It's just so
that's
hard
over
being so
12.
intelligent. Oh my god.
I'm sorry?
You can just do anything over 12. As long
I keep writing
As
radical
long
signs
as-
for pi.
as it's the same denominator.
Well, it's got to equal 2 pi. So you can't just pull things out of there and just add randomly. It's got to equal 2 pi. So that's why 24 over 12 is 2.
Okay, so double the okay.
All right.
My team ordered this shit.
Okay, you guys are killing me. Here we go.
Yes, sir.
That do it on everything.
No, I thought it was-
So remember, here's something in your homework. So remember, theta, central angle, is going to equal arc length divided by radius. Well, that leads to another formula.
We won't
I really shouldn't have to give this to you, but we're going to write it this way, if you would allow me to talk. We're going to take the radius times the central angle is going to be equal to the arc length. So sometimes they're going to say, you know what, we know that the radius of the circle is 10, and somehow we know that that theta is 2 pi over 3. By the way, I just want to tell you where we're kind of headed with that, okay? That's actually what we call a polar coordinate, okay? Or a vector. Do you guys remember Despicable Me?
Yes.
The very first one, which is the best one of the series?
Yes.
Okay. Who was the
Vector.
bad guy? What was it?
Vector.
Vector, and he did crimes with both
Velocity and magnitude.
direction,
Oh, direction.
direction and magnitude. This tells me the direction. This tells me 2 pi over 3, so I'm going this direction, and this tells you how far. You're going to go out a radius of 10, and that's a vector. It has distance. It has distance and direction, or magnitude and direction.
Isn't like velocity like,
So how
isn't it just like speed, but like to like a certain direction?
So speed and velocity are a little bit different from what we're talking about here, but with velocity, it does have a direction.
Like,
But it's a little bit different. Vector is just more a distance as well as a direction. So this particular one, if I wanted to measure the arc length of that circle, you would simply take 10 times 2 pi over 3, which gives you the arc length. So now, remember, I'm using it into a formula. Pi isn't 180, pi is pi. Pi is 3.14. Okay? So you simply would multiply, and you get 20 pi divided by 3 equals s. Use your calculator, or you can leave it just like that. The arc length would be 6 2/3 times pi. 6 2/3 times 3.14, so somewhere around 20. Have you calculated that out for me? 20 times pi divided by 3. What'd you get? 20 point what? So let's just say if this was in inches, this over here would also be in inches, it'd be 20.9 inches. Feet, miles, whatever unit it is. All right, that's it for angle measure in radian. Next time we meet, which will be Thursday, we'll start talking about the unit circle.
Wait, that's it?
That's it for this lecture.
Oh, 20 minutes of spirit.
you have time to do homework.
You have homework?
It said no
Why-
homework.
why- why- why did it
The
say
board
there's
said
no
no
homework
homework.
over
It
there?
said the board said no homework.
What?
Yes.
Yeah.
Go
What
back
said
on
no
the
homework?
first
Go
page.
back.
No, like, you can actually like.
Man. What do you, wow.
Hey, Gabby.
Equal upset.
I have a feeling that was after the test on Thursday.
It
No.
I probably just didn't change it.
It said October 17th.
Hey, you know, sometimes I make mistakes.
I got you, brother.
Mistakes like this.
Certainly not going on this
I don't want you
section.
to want to know, man.
I do, I like this, man. I love chicken on the tray.
Now, it may seem like a lot, but I am giving you some problems that,
We just went over it.
Huh?
I'm keeping this.
Ça va bien.
I am not proud right now.
It's like a truck,
There you
Gina.
alright, that'll be on Schoology.
Is it on, can you put it?
It is.
It is? Because last time it wasn't.